My name is Shawn Hurst. I'm a solutions architect covering the Mid-Atlantic or Central U.S., Chicago, all the way down into Texas. I've been with NGINX for about a year. Had previous experience in working with the product line, both as an open source product and also some implementation. Looking forward to talking with everyone about this particular topic. So we're going to cover a little bit of introduction. Hey, I've already done that. And we're going to talk about Allison Bob because it's not a cryptographic discussion without talking about Allison Bob. Then we're going to go into some endpoint identification with mutual TLS and how we can actually help in this particular subject. And then we'll have some time at the end for questions about the topic. So, Allison Bob, or who do you really know? Allison Bob have actually been the subject of a number of different conversations in the cryptographic world. Anyone here actually know when the first reference to Allison Bob was as part of a cryptographic discussion? Feel free to raise your hand. Sure.
Was it the how to have a conversation in a full room? Like there was a paper, was it one of the original RSA papers where it was like how to have a conversation?
Yep. Allison Bob want to exchange information. Specifically, Ronald Rivest, Avi Shamir, and Leonard Altman all introduced the concept of Allison Bob. The first paper that talked about public key cryptography, for the record, first public paper. There are some that actually predate that have recently been declassified, talking about public key cryptography prior to the entrance and for public consumption. But they talk about that in their first paper. And then everyone else that's ever talked about cryptography in any subject matter has also talked about Allison Bob, specifically around the concept. The first reference that we really talk about this is John Gordon. John Gordon actually gives them life. And you can actually read about this. I'm not making this up. If you look up cryptocouple.com, you can actually hear about all the things that Allison Bob have done. For the record, they've been day traders, they've been married, they've recently been divorced. They're actually trying to talk about their divorce topic, through this. They want to play poker across the internet, like crazy stuff. But with that said, Allison Bob always enter into a conversation because it's a nice, easy way to actually have a concept. Everyone knows who Alice is. Everyone knows who Bob is. You have an eavesdropper, and that person's name is Eve. Cleverly named, but it gives us a lingua franca to talk about these subjects in a way that works. And the traditional example for this one is, hey, Alice, hey, can I have your public key? Sure. Hey, let's encrypt it. Great. Anyone see the problem that exists in most of these conversations? Oh, wow. It's very sensitive today. In these conversations, how does Alice actually know who Bob is? In most implementations for TLS, we actually have a reference. You have an assumed known endpoint. It's got some sort of characteristic or identifier that you're using that's usually tied to the cryptographic circuit or certificate that's talking about here's where we can expect to find Bob. So Bob sits here in his chair in our virtual environment, and Alice is anywhere that wants to talk to it, and she picks up the phone and calls him and makes sure that it's actually him. And we see that in most implementations. If you go to any site, basically that certificate is tied into both a SPI and other record information about that. We always know who Bob is in the Allison Bob conversation. It has known accessible point, in most case URLs, and a web of trust, the certificate exchange that we use and hate. Allows checks on identity to actually make sure that this certificate has not been altered, that we know who we're dealing with. Well, these work great in the concept of a normal implementation. And how many here actually have ever done I have one server, I have one client, I don't have any load balancers, I don't have any other pieces of traffic in the way. Usually there's not just one Bob, there's multiple Bobs. We have some mechanism to actually split this load across multiple endpoints, but by and large, when we're talking about conversations in this environment, we know who Bob is, or the Bobs are. If you don't know, this is from Office Space. Here's the other problem. How does Bob know who Alice is? Generally, he has no clue until you've actually completed the chain and actually put together your TLS session. Bob really has no clue who Alice is. The only really thing he knows is Alice has a public key that his private key will actually decrypt. You can infer a lot of information about this. You can look at the IP addresses, a sign-in, security tokens, all sorts of things about the conversation. But contained within the conversation itself, we have a known party and some random person outside of this environment. It's not a great environment if you're Bob. You don't know a lot of the times who you're actually dealing with. One of the mechanisms we actually use to ensure the environment and we know who we actually are talking to is mutual TLS, or a mutual exchange of information between both parties, so both parties can instantly identify one another. So we go back to Allison Bob, and they want to exchange some information. The security posture is a little bit different in this environment. The first question is, who are you? And this is relatively normal in an environment, like if we apply this to the real world. If I came up to you and said, hi, I'd like to give you some money for stuff. As a normal human being, most of the time, like, I kind of like to know who I'm doing business with on both sides. And more importantly, I want to be able to prove it, especially if it's something of a sensitive nature, financial transaction, for example. So we ask for identification on both parts as part of mutual TLS. And this kind of works in the exact same method that we're used to. Both the server and the client present a public component of a key, usually a certificate in those environments. Both go through the certificate validation chain, and then we continue with normal TLS negotiation. If you've ever looked at TLS, it's about 9 steps for an interactive TCP session to establish a TLS link. For mutual TLS, it's about 12. Where at the server, once it's actually established the first connection, asks for the client certificate and it goes through some back-end checks. It doesn't really add that much a difference. So you can actually go and answer questions like, which Alice are you talking to? Are you talking to this Alice or that Alice? For the record, this may make some differences. Personally, I'm going to be going to the Alice Cooper concert as opposed to talking to a crazy woman. And if we're looking at this as a much more interactive piece, this is actually how this ties together. Notice that they're both going to external certificate authorities. They're both actually going through checks, and both sides of the conversation are actually encrypted with different sets of keys. Now, this does create some other issues associated with mutual TLS. If you're trying to decrypt a session, you actually have to have both sets of keys. It makes it a little bit more difficult from a troubleshooting perspective, but it does offer another layer of security in these environments to actually present this. So, in these two cases, we end up with a much more long-term, reliable connection between these environments because both people have some skin in the game. So, let's talk about how NGINX can actually help both Alice and Bob in these environments. Traditionally, implementing mutual TLS has been a bit of a complex subject. You have an additional load that's actually happening on the side of the server for any TLS session. Now you're putting some additional load again to do an external certificate lookup for every inbound client connection. And while these introduce about 8% over a traditional TLS implementation, shavings make a pile. So we've actually done this for the number of customers. Specifically in my area, I happen to cover a patch that has quite a few financial organizations. Midwest has got a lot of insurance companies and banks, surprisingly enough. In these cases, what we actually have done for most customers is actually implement an additional layer in front of their existing application servers, very much like a certificate offloading layer. We and usually incorporate this with some sort of routing and management in those environments, but we try to leave the backend environment relatively unchanged. That way we can actually, especially for an application that was never intended to actually have this level of certificate or additional load, can actually manage that pretty seamlessly. We can also deal with that application load by extending this case. And this is where we actually can show some real differences in how NGINX can provide support for customers that may have a much higher security requirement, whether it's a PCI compliance issue or some other regulatory compliance where they have to have a positive identification of the persons that are actually communicating with them, and an IP address isn't going to meet that criteria. Even login credentials aren't going to meet that criteria. Even an external security token in those environments can meet that. In these cases, we can actually look at the criteria that are being presented by the security certificates that are coming up, such as the DN specific or serial number to make sure that a new certificate hasn't been inserted in the environment, fingerprint, or in the case for most of my customers, the issuer for the DN. They don't care about the security credential itself. They want to make sure that someone has gone through the appropriate external validation to prove who they are, and they have a very small listed group of security providers that they will trust to sign those security credentials. Problem is, when you're actually dealing with security certificate, you're establishing a connection, and then you have to unpack that security credential and then start inspecting the criteria coming in for it. Maybe have to parse it, write a whole bunch of insert interpretive language here as part of those environments, and that can be significantly impactful for the applications that you're supporting. In our case, we actually used a couple of different features. We were actually using NGINX Plus for this environment. So we actually, when the security credential is presented as part of the session, a whole number of tokens are actually created on that. And we can actually use those tokens to handle information related to how we want to look this up. We can simply do, all the parsing's already been done. I don't have to write a layer to do with this. I just pull a token out that I'm interested in this case, the issuer DN, and say, if it's this list of issuer DNs, I'm going to actually allow it through. If it's not on this list, it's denied. Nice, easy, simple to manage, simple to explain, and easy to actually add some additional functionality to. For those of you that weren't aware, we have added some additional function into NGINX Plus, one of which is dynamic recertification. In those environments, one of the biggest criteria that they had was they have a hardware security module that they are using as part of their encryption. They want to retrieve information from that. Did anyone here actually go to the most recent Black Hat conference? Yes. Did you get a chance to hang out in the Hi, we figured out how to break hardware security module conference? It's a really long and much deeper technical talk than we're going to be dealing into, but what they were able to do was actually use some fuzzing and be able to retrieve private keys for hardware encoded modules. Now just think about that for a moment. For those of you that don't have a security background, allow me to explain. Literally, they walked by with a Raspberry Pi and a radio, a very well-tuned radio, mind you, and were able to drive by, get a copy of the private keys for a bank's ATM network. You can understand why this conversation came up recently then. One of the reasons that we actually can support this environment is being able to actually inject a security certificate using the existing API for NGINX Plus. Push that as basically a JSON object so that that never lives on the disk. It only lives in memory, and it can live in memory in a format, hopefully, in an environment where they can actually perform that type of attack. Now there's other mechanisms you can do with that, hammer row, other criteria you can actually use to retrieve that. But it's another layered, nuanced way to actually add an additional layer of security in those environments. And we actually do this both on the server, in the particular use case that we were dealing with, the client happened to also be an NGINX box that was serving as an API endpoint to establish a connection for a trusted payment network. So what they could actually do is if they believed that the criteria or any of the security credentials for that were compromised in some way, they could actually push a new certificate without having to affect that production network and immediately recertify all the points for that 2,000 node network. Nice and easy. If anyone has here ever had to recertify any of those components where you actually had to put a new security certificate, you will understand how very happy they were to have that conversation. And that also allows them to make a change in that environment without reloading the server or the load balancer in those environments. So not taking traffic offline, not killing sessions that are already established, being able to do so in a transparent mechanism. So I've done a lot of talking. Now I'm going to do some showing. Specifically, in those cases, what we all really had to do is actually turn on the location API. And you've probably seen this 100 times. In the cases for this, they wanted to restrict it to a specific security credential. Obviously, localhost is probably the most secure, but this one they had a list of known addresses that they were dealing with. We did some extension off of the existing logging format. You can actually see that we added a couple of records. The client fingerprint. client DN information and pass it directly into those environment variables we're talking about. SSL Client is the endpoint for all of these. So you can actually reference SSL Client in the documentation. There's about 40 of them. Any of those are directly accessible once a client certificate's been presented to NGINX Plus, and you can use those as any of the decision criteria for the example we're actually providing in here. We also do an allowed. Allowed is just an environment variable we'll set up a little bit later on as part of this example. And verified. Every time the security certificate is actually gone through that process for NGINX, we record it as a variable. Yes, we don't know, or no, and here's why. Here's the criteria we use that prevented validation, and there's a couple of listed directives behind that. It enhances the troubleshooting process for this particular use case. We just set up a quick upstream backend. Obviously, it was not Bob's house of pancakes. I have a couple of other names, but that one I'm pretty sure, by the way, that is still available. I'm thinking about registering it. And then we set up a key value zone. We just basically tied in 5 megabytes of SSL Client DN to actually store the information that's coming in. And we set up a key value that shows the DN and then set a client allowed. In the use case for this one, I'm just doing the client certificate DN, whatever's issued to it. I pass that into that key value store and give it a allowed value of 1. And I give it a zone name to actually make this work. And then we set up the server in this case. Obviously, this is not a complete server definition, just a quick demo if you want to actually try this out on your own. I would absolutely encourage you to do so. Let's Encrypt will give you a security certificate and plug it into NGINX for you. Makes this really fast. So we give it the security certificate for the backend that we're actually supporting. In this case, Bob's certificate and key. I set it up for TLS 1.3 because I'm a masochist. And the client certificate that we're actually presenting to the backend. And notice in this case, I'm actually putting the connect root. You can actually get away with this. It works really well. It just pulls the certificate for the machine itself and then actually presents it into the backend. Verify client depth on. If you don't do this, then half of this verification goes away. Now, there are differences of opinion on this. I will present to you that in my 20-some years of public key, I've never seen security certificates go past 4. There are some security best practices that dedicate this to be around 10. If you have 10 layers of intermediates between you and your root, I would like to talk to you about some management opportunities that I can provide for your organization because that's a lot of security components. In this case, I left it at 3. 3 actually catches most of those criteria. If I don't go past 3 and you have more than that, I will reject you and I will give you a line that says couldn't complete chain validation. And here's how all this works. So all of this stuff has been right to this point. We have an if directive. Client allowed is not 1. Return 403. Now, I want to say this with a caveat. Notice that we're in the server block and we're actually looking at this criteria. You may want to do this in the location block. You think that that's a great idea. Don't do it. And there's actually a web page on our documentation that specifically talks about if in the location block is evil. It really is evil. And the worst part is this will still work. This is one of the allowed use cases in the location block. If all you're doing is returning a 403 or returning some value as part of the connection piece, it's allowed. Generally, if is a very powerful tool and use it in the server. It is restricted for the module to only be supported. And if you use it correctly, it will not cause problems. If you try to use it in location and try to do all sorts of fancy things with it, like change header information, no, it does not work well at all. But those sets of blocks, coupled with the connection for the backend, will actually get you an environment where you can actually do mutual TLS with NGINX as a proxy in those environments, and gives you some criteria and control to set up an environment that you can actually front end any of your existing solutions without putting the additional load for it for mutual TLS. Now, let's talk about this from the perspective of this is a really nice example and this is very basic. Let's be completely frank. The same pattern works for all sorts of other use cases. More specifically, it works for use cases like microservices. I have a Kubernetes ingress controller that I want to actually set up to do mutual TLS through all of my container components. Same component applies. By the way, that becomes even more important for dynamic recertification. We can actually push the certificate in as part of your configuration so you're not storing secrets in your immutables. You can actually configure it with a dummy component, turn on the API key from a trusted endpoint, push the certificate in, and no one can go back and look through your configs and actually pull that information out to give you some problems in those environments. You can also set it up as part of your CI/CD pipeline when you're rolling those components out to push that as part of the configuration. So, I wanted to give people some time for questions on this one because this is a loaded topic. There's lots of different ways that you can actually go about this. So I wanted to give plenty of time for people to actually ask questions in here. Please feel free to raise your hand. We'll pass the microphone around. Please wait for the microphone to come up because we are recording this. Somewhere will end up on YouTube at some point. I'm very scared of that, but please, right in the back.
If the certificate has an extension pointing over to like a CRIL URL, can you in NGINX go and fetch those and walk the chain?
By default, we actually go through that chain walk. Give me an example of an extension you're...
I don't know what it is exactly, but instead of having all of the certificates and all the intermediates there on the machine, it will say like here is where you can go to get the extra certificates that you need to validate the chain.
The certificate revocation, and yes, it will actually do. We've had a test case specifically around that. I have an environment where I've done a ADFS certificate store with unknown intermediates to test that specifically, and it was actually able to traverse the entire piece and pull the revocation list for all the intermediate endpoints without having them presented in the PEM. What other questions? Wow. Please.
So we've been trying to get this to work with NGINX open source.
Mm-hmm.
So how much of this is doable there?
The only piece that you really have an issue with is in the key value environment. You would actually have to come up with a Lua or an external module to actually reference this, where you write some sort of lookup component and then return a value. It is doable. It's significantly easier on Plus simply because we've got kind of the functionality baked directly in.
And if you have a longer chain, let's say 3 or 4, right?
I'm sorry, I didn't hear.
If you have a longer chain
Yes.
of certificates, right? So let's say 3 or 4 certs. So from what I got, we are able to verify that the root is trusted. We are able to verify the issuer DN. But are we able to actually kind of verify
We walk
the
the
chain
entire
as well?
chain, and that's why you have to set the depth.
Okay.
Because there are a couple of known vulnerabilities that have surfaced in OpenSSL talking about an excessive chain as a denial of service. Mm-hmm. So you do want to set some thresholds that say, okay, if you've got 10 like intermediates, you're doing something really wrong. Mm-hmm. However, and I joke about this a little bit, I have seen some public implementations for this, specifically around things like DocuSign. Where DocuSign actually has multiple intermediate certificate authorities. So you can actually see DocuSign where we're using NGINX as a proxy in those environments where it had 6 intermediates. So understand that's one of the reasons why that block for the logging actually calls out like, why did we reject this? It should be added to here. So we could actually say, nope, verification didn't pass because we exhausted the certificate chain. Yeah, that's a really good question, and it's one that makes sure whatever you're doing for your formatting in those environments actually references that directly. If you don't, it can make troubleshooting on a solution like this incredibly difficult.
Good. Yeah.
What over here?
Question regarding gRPC. You guys have any experience with it, having mTLS enabled between 2 microservices in the same cluster talking gRPC and has to do, authentication, are you guys terminating it on the NGINX, the mutual TLS, or letting it flow all the way to the other service?
In Google's implementation for these, there's differences in the performance that we can actually get depending upon what container or virtualization platform we're deploying. This is an excellent question. Thank you. In a lot of traditional virtualization platforms that we can present, let's use VMware as an example. VMware, if you're doing a VMware VMX type of network interface presented, anything that's on the core functionality of the network interfaces is automatically passed in. So if you're using a Broadcom or Intel or something, that actually is surfaced up to the underlying operating system, and we can leverage that as part of OpenSSL implementation. So we can actually offload certificate component and lookup and cryptographic. In Google, that doesn't exist. For one reason or another, they have not decided to expose that functionality. By the way, that functionality also exists in some implementations if you're doing an AWS or Azure. And you can actually you can go into the weeds for this, but you can actually use some of the FPGA or ASIC environments in both Microsoft's environment as well as Amazon's environment, and actually do load in some certificate offloading directly in those. And we actually have support for those that's actually at the OpenSSL component. So it'll actually push the offloading in for certificate, and you can get almost less than 1% for actually turning on these solutions. And you can expose those into a Kubernetes environment running in those spaces. It's a really interesting use case. It's not cheap, because you're actually in those stacks where you're actually, those are very expensive resources to leverage. But if you have a extremely large scale environment that you're running in public cloud, those are the pieces that you would really want to investigate, simply because if you don't actually have some way to offload that in configuration, you end up being CPU bound very quickly. So if you are doing it in your Kubernetes in Google, you need about double the configuration for your containerization. But depending upon the workload that you're actually doing and the regulatory environment in which you're dealing, you may be required to. What other questions? Feel free. We've got a few more moments, I believe. Yes, please.
Hey, thanks for the session. So I have one question today. We are pushing NGINX instances using Azure DevOps, and we are grabbing the certificates from the Key Vault. Mm-hmm. It's downloaded inside a virtual machine, and then we reload the configuration. Mm-hmm. It's pointing to /etc, NGINX, blah, blah, blah. How can I switch to the dynamic certification you are talking about?
Well, what you're actually doing is there's an API command specifically in use cases like this. We were actually doing it as part of a proof of concept. So curl command, mm-hmm. put, or post and go. And that will actually load a certificate, and it will, instead of having to do the reload, it immediately starts taking effect. Mm-hmm. Take that with a grain of salt. If you're doing solutions that are using HSTS or any other type of certificate pinning, they can freak out because you've actually changed the certificate. Like I was just talking to it, and now I'm talking to it, and it's got a different certificate. There are ways to actually void those connections and force a reload for the other side. There are extensions specifically in the certificate library to deal with that. But understand, anytime you're changing a certificate that's client-facing for like a public web browser, it can be a problem. Mm-hmm. If you're not doing it for a web browser, it literally is curl put, here's the API key, and here's the JSON value for a certificate, and corresponding, here's the private key, push it to the component, and immediately every connection starts using it.
Okay.
Without a reload, without anything.
Good. And how is it is kept if I reboot the server?
Depends on how you've configured your state information for API.
Okay.
Has anyone here actually used it? There's a conversation for API commands are not automatically written to disk. There's very important reasons why we don't do that. The reason for this is specifically to handle these use cases. Sometimes you don't want that file written into an area on disk for session reload.
Sure.
if you're doing this as part of your CI/CD, when you're instead of doing a reload, you're just creating a new instance. You created another instance, push the configuration out, or manage it through those environments. That's the safer way to do it. There are regulatory reasons specifically not to do that. However, if you're not in one of those regulatory environments where you have to worry about that as a case, you can turn on a state file, you give it a known location in the operating system. The next time that you do a reload, it reloads and then plays back all of the state commands that you've actually had written to disk, so that it gets it back to that known state.
Okay. Thanks.
Any other questions? Excellent. I'm glad to. And again, I'll give some source specifically talking about mutual authentication. The URL that I was talking about before, CryptoCouple, go check it out. It's great for like killing 45 minutes and going, wow, I did not know that this was still going on. A couple of examples that we actually have for those, and some of the references that we're talking about for timing and other came from Bruce Schneider's book, which always puts me to sleep after about 14 minutes, but you know. Again, my name is Shawn Hurst. If you have any other questions, I'm going to be over at the booth just around the corner here. I'll love to talk to you individually if you would like to have a one-on-one conversation. Thank you for your time today.